Hello students, welcome to the lecture. Today we are going to see a case study on electric vehicles. So there are many things in an electric vehicle, right? So there are many things. For example, in electric vehicle, we talk about the range. That is what the first primary thing. Am I right? Range. The next thing is about the capacity, battery capacity of the electric vehicle. Am I right? The cost, etc., etc. So in today's lecture, right, we will pick a case study, right? So Ritik is here, right? So Ritik is designing his electric vehicle, right? He is designing his electric bike. So let us discuss what are the things he faced during his fabrication, and we will have the sort out the solution for the issues and troubles. Yes.
So basically, I'm a electronics engineer. So I'm designing an electric vehicle for the events. So many events are occurring in this range. So I'm designing a vehicle. In the last event, I have been facing some problems, which is mainly the main race. While we are driving the vehicle, we have been using 45 amps, 45 volt MCB with 2 kilowatt battery and 2 kilowatt motor hub. So the race is about 45 minutes. But even though we are driving with the economic level, means the MCB is getting melted. So we are facing a major problem and we can't be able to win the race. So this is a major occur we are facing in this endurance.
That's it.
Actually, if we are speaking about the fault that occur during Ritik's design, right? So there are a few things that should be considered while designing the vehicle or harnessing the vehicle, right? Because it is an electric vehicle, am I right? It is not a mechanical thing, right? So it should be taken much priority because there are many wirings and many things that are inside the vehicle, am I right? So we should be cautious, right? So here Mitesh is one of the automobile student who is actively designing his electric bikes, right? So let us have a view about what is the fault that may be, what are the possibilities that can occur because wiring is one of the thing. What about your views, Mitesh?
Sir, while I was fabricating the project. So I have used 48 volts of supporting motor and 60 volts of battery. So while using that, the MCB was sufficient for some days. So after some prolonged use, the same problem occurred for Ritik as occurred for me. So MCB was failure and delivered some shots and fire happened. So after that we didn't just change the MCB. We just took the melted wire out and we attached a new copper wire which has a bigger thickness than the already burned out wire. So after that the problem was solved out. We just won the race and we came to college. But the proper thing to be done in this case is we have to measure the already burned thickness, and the copper has a particular connectivity. So for this much thickness, there are a particular range of connectivity. So for supporting 40 voltage, 48 voltage and 60 voltage, and many advanced electric vehicles use more voltage of power electronics in them. So to manage that, we have to use a bigger MCB. So just for going to a shop and buying a better and a bigger MCB, we can just swap out the copper cable inside them, and we can use a better and a bigger current carrying copper wire. And if we have to also consider this particular thing. We should not increase the thickness of the copper wire very much. So if we put a very thicker one, the current will be carried away very faster, and the motor will be in a danger. So it could have become fire and it could gone wrong. So we have to do some calculations, and a particular thickness of wire can be swapped out. One of the solutions.
Starts.
As Mitesh told the solution, I would like to add my point, right? So here what we design is an electric vehicle, right? So while designing the electric vehicle, in this case particularly the melting, right? The wire gets melted because because of the long run. Am I right? 45 minutes you are running in the track, and afterwards the MCB or the wire may get faulty. Am I right? That is melted. So here I would like to suggest that the electronics part of the vehicle should be considered according to the their capacity. For example, if the motor, right, what is the voltage system, and the MCB, what is the operating ampere, right? So accordingly we have to predict the wiring, right? For example, 2 mm square, 4 square mm, am I right? Likewise, the wiring harness are specified, right? So that can be chosen according to that. And other than this, yes, so the limit of use is to be considered while designing the electric vehicle. So there is one more student with us, right? His name is Kavin. He is an intern at Radba Motors, right? So he came across many electric vehicles, right? So let us hear from Kavin's point of view.
As we have found in electric three-wheeler, yeah, battery has melt the MCB because of the high voltage comes from the battery. This case we have use a CAN battery that will reduce the current for required area and required load. This will arrest the MCB melting and other issues, and also give a maximum range of the motors, and reduce wastage of current. This we want to use CAN battery. It reduce the all 50% of electric problems in electric vehicles while running or on standing without any operations.
Yes. Yes, actually, so far in this case we have discussed, am I right? The fault here in this case is about the wiring, right? So what the other suggestion from the industry perspective is to use CAN. CAN is nothing but it is abbreviated as Controller Area Network. So this optimizes the energy and supplies the energy according to the need. So how the torque is required, so how the current should be supplied, right? So likewise the CAN will supply all those things to the motor, right? So this controls the energy flow. So this can be one of the solution for this case, right? So let us try to incorporate the CAN, implement the CAN in our vehicle to rectify our fault. Then if it is again occurs, then we will discuss that thing and we will incorporate the suggestions in the future, right? So I thank all the students for joining here for discussing about the case, which is a real-time case where we design and fabricate. We do many things in our labs, right? And this should be considered while we have to hear from others' point of view, so that we can rectify our faults and we can succeed in the future. Thank you.